Then we need to find a general formula. That's for continuously. Okay. Now, look at the pattern right here. We may look at both. And then you can see, let's look at this one. Here is the rate, 0.03. And here is 100. Here is 1, so nothing changed. And here we do 1 year, the end of the year, the end of the second year, so the end of the fourth year. So here T stands for the number of years. Okay. What's the meaning for N? Look at here. N actually is at the place for 12 for 365. Okay. So actually N here can be 1, that's annually, and can be 4, that's quarterly, can be 12, like here, that's monthly, can be 365, that's daily. Yeah. So it can be like every half a day. So anyway, N here gets bigger and bigger. So N may goes to infinity. You may put 10,000 here. Okay, N can be 10,000 or 100,000, 1 million. So we want to explore is that when N gets bigger and bigger, how they are going to affect the whole quantity. Let's do a little bit math here. N is the number of compounded periods in a year. So here let's use 0.03 to divide N and then times 0.03. So 0.03, 0.03 can cancel each other. The reason I'm doing so is that I want to study this quantity. Okay. You see right here, this quantity is basically the one right in the middle here. Okay, don't look at T, don't look at 0.03. It's the one right here. Okay, 1 plus 0.03 over N to the N over 0.03. That's this one. Yeah. So we want to study this quantity. Okay. Let me copy this quantity down here. Look at this one, this quantity. This quantity, again, N can choose different values. Okay, you can choose N. It's 1 for 12, 365. So here you have N, 1 for 12, 365. You can choose 10,000, 1,000, 10,000, goes to infinity. What will happen here is we'll find out this number. Okay. Now, in order to find out this number, let's use the calculator. Look. How to find out this value? Here is the way. After you turn on the computer or the calculator, press this one. The screen is not clean, so you want clear. Okay. You want to input this one into your calculator. So you want to do is write y equals, click on that. Okay, click on that, and then you input is parenthesis 1 plus 0.03 divided by n. We don't use n here, we use x. X divided by exponent is 2, this arrow to the top, and then close parentheses, input x divided by 0.03, this one. Okay, and you have the whole expression in there. Don't forget the close parentheses. Alright, and then you go to the table set. You are done here. Y sub 1 is the variable, and then you do table set, you do second table set. Make sure the independent variable x is ask. So you move it right here and hit this enter. Okay, then you are done with how to input the independent variable. They will ask you each time. You then go to table set. That's second table. They will ask you. Okay, the first one, if you input 1 here, I have values already here. If you input 1 here, it gives you 2.6786. How did I get here is 2.678598. You know, you can move the cursor to this place and the detail number will show up. 2.678596, so round it up. Okay, here is 98, and then you move the cursor down. They ask you another value. You move the cursor here, input 4, and then hit enter, and then you have 2.708. Here I got 1, here is 2. Why? Again, move the cursor here, you will see the detail number down here. 2.7081578 rounded up. Okay. Move it down here, you can find out 12. Okay. And then input 365, hit enter, 1000, hit enter, and then 10,000. Oh no, 10,000. 10. Hit enter. You can see the value here. 2.718278 rounded up. Then you can see with n increasing, previously from 6 to 7 for the first digit after decimal point, then 7 is never changed with the number increasing. And then from here 7 0, here you have a 1, and here 1 1 1 will never be changed as n gets bigger. And then you can look at the third one, third digit. It was not stable, and then 888. When number of n is increasing, you will see the third digit will all be 8. And then, you know, when the number gets bigger, you will see the fourth digit is going to be 2. Okay, and then again, with number gets bigger, you will see the fifth digit will be 7, never changed. So this number, as increasing, you will see E. Okay, this number is eventually goes to E. and this E is an irrational number. Irrational number means the number here, the decimal number, the decimal digits, never ends but never repeats. There is no rule to follow. That's why we call it irrational. So E is irrational. Every calculator has E. Okay, let's get out of this state. Alright, yeah. So second quit is out. Where is E? E is right here. You see? Second, here is yellow one, E. You may put one here. Hit enter. That's the number E. 2.71828 something here. A little bit more. So that's for the compounded continuously, you want to use E. That's the point. Okay. Now we have this formula here. Okay, and that's this one. So when n gets bigger, you want to replace this whole quantity by E. That's the point. Now this whole quantity is E, you may write it here, and the exponent is 0.03 times T. T is the number of years. 100 is the initial amount, E is the irrational number, 0.03 is the annual rate, T is the number of years. For compounded continuously, if it's at the end of the 4th year, so replace T by 4. 100 times E to the 0.03 times 4, close parenthesis, you'll get this number. 112 times 0.749685. You see, that's slightly bigger. Here is 749. Here is 74912. Here is 7496852. So slightly bigger than daily. Okay. Of course, compounded continuously is much better. Okay. This lecture basically tells us where E is from. Okay. Where E is from actually right here. Yeah. So please review this lecture, and then I will see you next time.